Everybody knows Bob goes by the nickname Hurricane Bob. And you think it's because of his hurricane forecast, but what everyone who knows Bob is a true force of nature himself, but a force for good. And I was thinking, when I'm going up there today, and I want a nickname too. And as Bob said earlier, today I'll be Resilient Rob. And resiliency has many definitions. For today's session, we can describe it as the ability of communities, infrastructure, and businesses to withstand, absorb, and recover from disasters like hurricanes. Some common synonyms for resiliency include adaptability, toughness, buoyancy, elasticity, and flexibility. This is how we all had to be to cope with the hurricanes of the fall of 2024. For me personally, I remember standing with my family in the eye of Hurricane Milton and being at awe at how quiet it was, but then also in awe at the roar of the second half as it came barreling back through. And also, as Selby Garden's pro bono safety consultant and husband of its CEO, I remember the awe in seeing the resilience in action. Phase 1 of its master plan did exactly what it was designed to do. And I think we can all agree that, thankfully, the fall of 2025 was much better for all of us here in the Sarasota region. With that, it's now my pleasure to introduce Stalworth Stu, Dr. Stu Waterman, CTO and Senior Scientist of the Climate Adaptation Center, for our first presentation, the historic 2025 hurricane season review, what it was and what it wasn't.
Well, thank you, Rob. So I guess we all know the hurricane season last year pretty much fell on its face. Not much happened, we think. It turns out quite a bit happened. And a lot of it is a wake-up call for 2026 and beyond. And let's take a look at that. So take a little walk through 2025. All of the numbers and stuff on the slides, don't worry about it because you can read them later. But the important things here, we only had 13 named storms last year, and only 5 of them turned into hurricanes. 5 hurricanes is way below average for here. However, 4 of them were major hurricanes. That's, 80%. I mean, it's a deceptive number because 80% is 4 out of 5, but that's a lot of major hurricanes for not much activity elsewhere. And not only did we get major hurricanes, but we got 3 Category 5s. That is so rare. It's only happened once before. That was in 2005, and we had 4 hurricanes that were Cat 5. So the other thing that's interesting in this is that the confusing number called ACE for accumulated cyclone energy. So that turned out to be, even though we only had 5 hurricanes, we ended up with an average ACE index well above average. And that sort of reflects what we're going to be worrying about in the future. So again, don't worry about the numbers, trust me. But if you look at the top line, which is the average from 1991 to 2020, so the 30-year climatological average for hurricane seasons, the average number of named storms is a little over 14. The average number of major storms is just a little over 3. So if you go to the bottom, 2025, well, we only had 13 named storms. And we had 4 major hurricanes, more than average. So we're overperformed in many ways in the wrong direction. Fortunately, we had no landfalling hurricanes. And that was literally good fortune because well, I'll show you what the accident that made that happen. So what we were looking at last year is really an on again, off again season. It would look like a regular hurricane season, then it would just disappear, and then it would come back. So we got a really late start. Hurricane season starts June 1st, and we didn't have any activity, not even a tropical storm, until late in June. But shortly thereafter, things started to pick up. We had our first Cat 5 was in August. And then we're starting in August, you're starting to get into the peak of the hurricane season. And we had a Cat 5, and we're saying, well, this is going to be more exciting than we would like. Well, then what happened was the opposite. We had no named storms for an extended period of time in what would normally be peak hurricane season. So from late August to mid-September, not even a named storm, much less a hurricane. We picked up in September, and in late September, another Cat 5, and then in October, a really serious Cat 5, and we'll talk about them in a little detail in a minute. So we peaked late, and we had this huge gap in the middle, and this is why. So our famous Saharan dust, it saved our bacon last year, because basically it started blowing in early summer and just kept going. And the Saharan air layer is interesting. It's about a mile up in the atmosphere, and about 2 miles above that, it's about 2 miles thick, a mile up. And it's very dry, it's very warm, and the dust is carried along with it. I mean, we blame the dust, but really it's the air mass that's the problem for a hurricane, because that strong easterly wind high up in the atmosphere puts the cap on our potential hurricanes. So it's what we call a vertical wind shear. So it smothers hurricanes, basically. It also smothers the hurricane formation in the first place. So that's why even tropical storms weren't available in the middle of the season, because there was so much vertical wind shear going on. This is an interesting chart, because this is the track of every hurricane last year. And you notice that they all boomeranged away from the East Coast. And what happened was an interesting meteorological problem. We had a deep low pressure trough all along the East Coast, centered over the Carolinas, actually. And that was pulling air in from the center of the continent, and also from the Gulf of Mexico and so on. And all of that activity basically buffered the East Coast against the approaching hurricanes, and they all veered off into the central Atlantic. So there's one of the boy, this is really hard. I'm not that flexible. If you look at there's an unusual track down at the bottom, the one that ended up unfortunately going through Jamaica, and we'll talk about that in a minute. But so we only had 5 hurricanes, but the amount of energy dissipated by those hurricanes was way above average. And it shows up dramatically in this chart, because the 3 big peaks in yellow are the big Cat 5s. The first one is Hurricane Aaron in and then followed by Humberto in late September, and then Melissa in late October. And if you look at that blue curve in the background, that's the average hurricane season. And you can see the peak is typically around the 1st of September, and then shortly the month of September, we didn't have anything, not even a weak tropical storm. Don't worry about all these numbers either, but the important thing here, if you look at the two columns of information, the last 25 years of the 20th century and the first 25 years of this century, and you compare the two, every aspect of the hurricane season has gone up. We have typically, not last year, but typically we've had more hurricanes, more tropical storms. The hurricanes have been stronger, and unfortunately the damage has been greater. So and not only have we had more hurricanes, but we've had more major hurricanes, and they're the ones that really do the damage. And I think this chart shows it really well. If you go to on the left side, you'll see relatively few major hurricanes. Right, these are percentages, so that's a relatively small fraction of all the hurricanes are made it to major hurricane status. But when you get further on into the future, into the 21st century, well, it became very common for hurricanes to become major hurricanes. And those are our major hurricanes from last year. Those are our Cat 5s. So 3 Cat 5s in one season, I mentioned earlier, that's extraordinarily rare. It's only happened once before in 2005, when we actually had 4 hurricanes of that strength. This is all the more impressive from a meteorological standpoint in the sense that it's a weak hurricane season, and yet we still had 3 Cat 5s. So the Aaron, Humberto, and then the biggest of all, Melissa, was saved right for the end. Melissa was an amazing hurricane. It's 185 mile an hour winds at landfall in Jamaica. Almost was tied the record for peak wind at landfall. Let's take a look at it in a little more detail. But it started really, it was interesting. Remember that little that track in the map below Jamaica? There was a tropical storm off the coast of Venezuela that just wandered around for a week or so, only moving about 3 to 4 miles an hour, not getting out of tropical storm status, but it had lots of warm water, so it persisted. It just kept hanging on. And really, that also is an interesting aspect of it, of that particular hurricane, because normally if the hurricane or a storm is energized by warm water and it sits there, well, it rapidly runs out of warm water, because in the past, most of that warm water has just been surface water. But now the oceans are getting warmer, the deep water is warm enough to energize hurricanes as well. So, and that's exactly what happened here. So this tropical storm just happily wandered around on the warm water, had lots of warm water down below, kept going. And as soon as the vertical wind shear that had kept it a tropical storm dissipated, it exploded into a Cat 5. It reached in less than 24 hours, it went from tropical storm to Category 4. And then shortly thereafter, Category 5. and then very shortly thereafter it hit Jamaica. The first time Jamaica's ever experienced a Cat 5, they were very fortunate in a way that it hit the western side of the island and not the more populous side of Kingston on the eastern side. But the damage was extensive regardless. And the loss of life and the damage to property was amazing. I mean, it's in total, all of its damage, it damaged at least 200,000 homes between Jamaica and Haiti and the Dominican Republic and the eastern side of Cuba. And of course, it carried with it very, very heavy rainfall. 36 inches in Haiti, and the damage and loss of life in Haiti was not because of the hurricane wind, but because of the flooding that occurred because of the rainfall. 36 inches there with 32 inches of rain in Jamaica in basically a day and a half. So what does this tell us about the future of Atlantic hurricanes, and specifically what's going to happen perhaps this year, perhaps next year? It's, as you can see from that chart, it's really difficult to predict the frequency of hurricanes that we can expect. It wanders all over the place. I think you can see a sort of gradual increase in that chart from left to right. We are getting, on average, more hurricanes than we used to, but it's still up and down. It can be a lot or it can be a few. But the one thing we can predict really easily is that the strength of those hurricanes, however many there are, is going to increase because the ocean is getting warmer and there's more and more opportunity for events like Hurricane Melissa, where the deep water warms just as much as the surface and provides sustained support for hurricane intensification and persistence. And the other thing is that we know it took a long time before this ocean warming became evident, but it's going to take a long time before it goes away. I mean, it's now steadily increasing, and it will do so for decades to come. And that means that the potential for intense, severe hurricanes is increasing steadily, along with the ocean temperatures. So what does it mean for Florida? Well, we didn't have any landfalls last year. This is great news, but it's a little misleading because we had 3 Cat 5s. It could have been a disastrous year, and it turned out to be a damp squib, I guess, if you like. But if you look at Hurricane Melissa, an incredible storm, if it had shifted 100 miles, just 100 miles to the east, then we would have been looking at a landfall in Miami or Jacksonville, we dodged a bullet with that one. And our particular situation here is even more at risk than it appears, because the Gulf Coast has this phenomenon called the loop current, and that's warm water deep down that comes in circles down and then goes from north-south down the Gulf Coast of Florida. And that's exactly the kind of scenario, deep warm water, that can rapidly energize a hurricane as it approaches landfall. And so far, we've been reasonably lucky over time, but it's exactly that. It's just luck. You can't count on it, and you have to be prepared for it not happening. So if we say there are, last year below average named storms, everybody goes, well, it's good news. It may be good news, but it's not for sure good news, because it only takes one, right? One bad storm and we're in trouble. So don't sit back and relax. If somebody, I don't know what Bob's forecast looks like. He won't tell me. But if it looks like, oh, another relaxing year, it's not gonna. Don't relax. Stay alert and prepare for the worst, because it could happen. It almost happened last year. So I'll turn it back over to Resilient Rob.
That's how you thought there.
But before Resilient Rob comes up, I love that. Wait, I'll take questions. Any questions? Yes.
Yeah, I'm interested in this accumulated cyclone energy.
Accumulated cyclone energy. Can you give me an elevator speech of what that means?
Yeah, I'm sure that the name was conjured simply because it made ACE out of the letters. But so it combines wind strength and duration into a numerical index. So it looks at the history of a storm over time, and how strong it became, how long it remained strong, and the duration of the storm as a whole. So we can, you calculate it for any level of storm, whether it's just a tropical storm or a hurricane. So it just gives you how to describe it. It's obviously basically it tells you what could happen, right? It's got, if the ACE index is high, that means there's an awful lot of energy in that storm. It doesn't tell you whether it was a Category 5 or a Category 1 or just a tropical storm. A long-lived tropical storm could have a high ACE index, just like a short-lived intense hurricane can. But it's the amount of energy that's available to do damage, if you like.
How would you compare that to these categories? How meaningful impact measure it? It's not something reported moves. So maybe I could help on this. So when you make a base, you have a Category 5 storm, and state's Category 5 storm 5 days. That has used up a lot of energy. 5 days, Category 5, 157 miles an hour, 5 days. So the ACE number for that storm is really, say we have a top storm with 60 mile an hour winds in the last 3 days. The ACE number is really, really low. Use up some energy, but not a lot. So when you have 3 Category 5s in a year, you add those 3 storms together, it turns out a lot of energy was used in that year. Whereas maybe you had another year where you had, say, 17 the main storms, but only one of them was Category 5. The ACE number might be lower with 18 storms than it was with only 5. So it's the intensity over time.
Yeah.
Those two things go together to make up ACE. Whereas the category number is actually taken at the time it's measured. In other words, are the winds the maximum amount that they have to be the Category 5 at that moment of time? it only may be a category 5 for 1 hour, but when you measure this, category 5 absolutely is right now. So does that make sense? There are 5 categories in stores, obviously. Category 5 is the highest. Some people might have a category 6, and I don't. One of the reason is because a category 5 wipes the surface of the earth clean. Once you've gotten that, it doesn't matter whether it's in category 6, right? Everything is not going. And I'm afraid that a category 6 would make category 5 seem less important. And so that's the reason why I'm not for it.
Here we go, Bob. Stu, Hurricane Melissa last year and Hurricane Milton the year before were both storms that accelerated rapidly from 1s to 5s, coming from different directions, though. Any similarities between the two that would explain that?
They're both rapid intensification examples. You know, the common factor is the warm water that fed them both. And that's really what it comes down to. If the water's really warm and the storm can stay over it long enough to get hotter and ever to get more and more powerful, then that's what happens. As soon as it hits land, and of course it doesn't have access to the energy from warm water anymore, then it starts slowing down. But yeah. So,
yeah, I just want to ask Bob and both of you that last year having those 5 major storms dissipating so much energy and luckily not hitting landfall, is that a bonus for us this year that a lot of that energy was sucked up and gone and took some of the deeper water too? Does that figure in on hopefully giving us a mild one this year too? Because you know, it keeps moving and moving it to the Antarctic possibly or something. Is there any correlation? Who wants that? Nobody.
Okay. So the thing, thank you, Steve. Thank you. I'm so used to talking, just talking, with or without a microphone. But what I want to say is that, so the issue is the Earth has warmed a lot. It's 3 degrees Fahrenheit warmer now than it was roughly 100 years ago. And that excess energy is warming the oceans. And that means that the difference between the pole and the equator, the energy difference the Earth wants to be in equilibrium. So it will do whatever it takes to create equilibrium. And these storms are one of the ways that it takes energy from one location to another. So hurricanes don't really go south over the equator to another hemisphere. The warm water in the tropics feeds them, and then they go up and take all that energy into the northern latitudes. And so it's not so much whether it does dissipate it in that annual time, but this year, of course, the climate is just as warm as last year. And the water actually in some places is warmer now than it was last year. I'll talk about this later. So this is the mechanism that the Earth uses to stay in equilibrium. And hurricanes are one of the ways that happens. So as long as the Earth keeps getting warmer, the land and the ocean, the more energy has to be redistributed, and hurricanes are a major way that happens. So does that make sense? Good.
Okay, and to stay on schedule, our last question, our own Elizabeth Moore.
Thank you. It's a quick one. It's actually just a point of clarification. You spoke about the dust from the Sahara Desert. Mm-hmm. Does that dust, as it floats westward, is that absorbing the humidity and disseminate it, and that's why it dries out the air?
It's dry to begin with. I mean, it's a dry, warm air mass that's moving across, and it's a strong easterly wind, so it's moving from Africa towards us. And the dust, it carries the dust along with it. The dust is interesting because it absorbs a lot of the sun's energy, and that keeps the air mass warm. Yeah, if you know what I mean. And so by the time it gets here, it hasn't really cooled off very much. But it's at least a mile up, and the air mass is 2 miles thick above that. So it's not the same temperature that we see down here necessarily, but it stays dry. What it does over the zones where hurricanes and tropical storms form is that it's so dry that you don't even see clouds. If you remember that image, off the coast of Africa, it was a beautiful, clear picture of the ocean, and further west it was cloudy. So, I mean, it does dry out the atmosphere enough so that clouds don't form, and those clouds don't get to become tropical storms, and we don't get hurricanes. So, that's why we had that big gap in last year's record. Any other questions? Great. Now we can have resilient.